Hello students, welcome to Sanjay Godavat IIT Medical Academy. I am Dr. Srinivasmurthy, Senior Faculty in Chemistry. Welcome to the video lecture program. Today we are going to start the topic stoichiometry. Let us have a discussion about stoichiometry. The topic stoichiometry contains the following areas to be covered. Number 1, laws of chemical combination. Number 2, mole concept. Number 3, methods of expressing concentrations of solutions. Number 4, calculations based on chemical equations, empirical formula, molecular formula, oxidation reduction process, balancing of redox reactions, and finally volumetric analysis comprising of simple titrations and redox titrations. Stoichiometry topic is a very important topic, almost finds its applications in all parts of physical chemistry, though in the NCERT textbook separately each topic is discussed, such as the first topic, basic concepts of chemistry, under which laws of chemical combination and mole concept are discussed, along with methods of expressing concentration. Calculations based on chemical equations is also a part of it. Empirical molecular formula determinations, that will be important for Neet and JEE mains examination. Oxidation reduction process is separately discussed in 11th class volume 2 topic. First topic will be redox reactions, under which balancing of redox reactions and a part of simple volumetric titrations are also a discussion. Let us start with the first topic, the laws of chemical combination. Before going to that, let us consider what is the meaning of stoichiometry. Stoichion, meaning is weight, metric, metron. On the whole will be a discussion related to weight measurements of substances involving in chemical reactions. Yes, let us start with the laws of chemical combination. The first law states, the first law is law of conservation of mass. A very famous law, usually discussed in physics. Matter can be neither created nor destroyed. This is being applied to a chemical reactions. When applied to a chemical reaction, with the same name, laws of conservation of mass, often will be called as law of indestructibility of the matter, means that matter cannot be destroyed, matter cannot be destructed, the meaning of that statement. It was proposed by Lavoisier and later tested by Landolt. The statement in general says that mass can be neither created nor destroyed, or matter can be neither created nor destroyed, but during a physical process or in a chemical reaction, it changes from one form to the other. This is a statement given, the mass can be neither created nor be destroyed in a balanced chemical reaction or physical process, but one form is changed to the other. One form is changed to the other. Let us consider a simple reaction if the reactants are completely consumed in a reaction. Many of the reactions will go to completion, the total reactants will be converted into products, the total reactants will be consumed in the reaction. For such a type of case, this logic will work. Total mass of the reactants is equal to total mass of the products. The total number of grams of the reactants will be equal to total number of grams of the products. But a special case may arise. In some cases, one of the reactant will be totally consumed, the other reactant will be left. Such a reactant usually called as excess reagent, and the reagent which is completely consumed is usually called as a limiting reagent. So, we do not go to the details now, but remember that when two or more reactants are being taken, the reaction will continue till one of the reactant will be completely consumed. The other reactants will be left unreacted. So, under such a condition, the same equation can be written even like this also. Total mass of the reactants will be equal to total mass of the products produced plus the mass of the unreacted reactants. means that the leftover reactants mass and the mass of the products produced will be equal to the total mass of the reactants. So, please follow the statement which is given. Matter can be neither created nor destroyed, applied to either a chemical reaction or a physical process. Now, let us, with the help of a simple example, let us make a discussion. A known, very familiar known reaction. Hydrogen gas is allowed to react with chlorine gas, producing hydrogen chloride gas. Experimental studies indicated that for every 2 grams of hydrogen, 71 grams of chlorine will be completely reacting with it, and the hydrogen chloride produced will be 73 grams. Suppose if I sum up the reactants, 2 plus 71 will be equal to 73 grams. The product produced will also be 73 grams, means that the mass of the reactants will be equal to mass of the products. Please do remember that in this reaction, both the reactants are completely consumed. After the reaction, no hydrogen is left, no chlorine is left. The total reactants got converted into products. While applying this law, need to be careful about a few reactions for which you cannot apply law of conservation of mass, particularly the nuclear reactions. Nuclear reactions meaning is the reactions in which the nucleus is going to involve. Probably the nuclear fission, nuclear fusion can be taken as examples of it. In this, some of the matter will be destructed, some of the matter will be destroyed, will be converted into an equivalent amount of energy. These reactions under normal conditions do not occur, under high temperature and pressure conditions only will be possible. So, therefore, we do not take these reactions as normal reactions, they are specifically told as nuclear reactions. So, law of conservation of mass cannot be applied to this type of nuclear reactions where mass will be destroyed. In all other normal chemical reactions what we conduct in the laboratory, generally the reactions either may be exothermic reaction or endothermic reaction or the reaction which do not involve any heat exchange. Please observe here, an example is given. 40 grams of oxygen allowed to react with excess of oxygen to give 56 grams of calcium oxide. What amount of oxygen is consumed during the process? We have taken here calcium, 40 grams is being taken, 40 grams being taken. Oxygen, let us suppose that x grams of it is involving in the reaction to produce the product calcium oxide 56 grams. I am applying here the law of conservation of mass. Total mass of the reactants will be equal to total mass of the products. So, reactants total mass will be equal to 40 plus x. Total mass of the reactants will be 40 plus x, which is equal to 56. Okay, 40 plus x must be equal to 56. X, if we are evaluating, will be equal to 16 grams of oxygen. Like this base, very simple numericals can be given in the board examinations. Let us go to the next example. Second numerical is taken. What weight of barium chloride would react with 24.4 grams of sodium sulphate to produce 46.6 grams of barium sulphate and 23.4 grams of sodium chloride. Here we have taken two reactants and the final products are also 2 in number. So, in such a condition, I am taking here a reaction, barium chloride formula is BaCl2 and sodium sulphate formula is Na2SO4. These two are combining, these two are reactants producing the product barium sulphate and sodium chloride. I assume that barium chloride is taken in x grams. Here, we need to remember one important point. No reaction, no chemical reaction will occur in solid phase. Though I am writing here BaCl2 and Na2SO4, BaSO4 and NaCl as products, reactants and products. The general meaning of the statement is both these two are taken as aqueous solutions, as water solutions, and the products produced will also be in water. Particularly here in this case, the product BaSO4, one of the product BaSO4 is a water insoluble precipitate, it will settle down to the bottom. Okay, so you please mean that this reaction is being conducted in aqueous phase. This reaction is being conducted in aqueous solutions, that is water solutions. So, barium chloride aqueous solution is taken, sodium sulfate aqueous solution is taken. When these two are mixed, barium sulfate, a white precipitate will be formed along with sodium chloride aqueous solution. So, this reaction if I imagine and I suppose that x grams of barium chloride is taken in the reaction. Like earlier case, the total mass of the reactants will be equal to total mass of the products. So, that total mass of the reactants will be x plus 22.4 and total mass of the product will be 46.6 plus 23.4. Please make the calculations. Equating both of them, x plus 24.4 will be equal to 46.6 plus 23.4. Please observe here, you are going to evaluate the x value as 45.6, means that the weight of barium chloride produced in the process will be 45.6. This is the second example. Now, let us go to the second law. The second laws of chemical combination, law of definite proportions or law of constant proportions. Law of definite proportions, when you are preparing a chemical compound by any method, for example, you prepared water, you prepared carbon dioxide, you prepared water, you prepared carbon dioxide, let us suppose. Okay, in the formation of that, the elements should combine in a fixed proportion by weight, in a fixed proportion by mass. Now, let us go to these statements which are given. This law is proposed by Proust. In a compound, the ratio of each element by weight or by mass. In chemistry, mass and weight will be taken with equal meaning. So, even if it is written by weight, you please consider that it will be mass. Remains same irrespective of its method of preparation or the source from which it is obtained. For that, let us just go to one example here. I am preparing water by 5 methods or collecting water by 5 methods. Let us suppose that hydrogen and oxygen will be, hydrogen is burnt in oxygen. The first method, hydrogen is burnt in oxygen. Hydrogen gas is burnt in oxygen to produce water vapor. On cooling, I am going to get the droplets of water. But please do remember that this water must be in pure condition, should be free from all the salts available. When I am taking pure water by different methods, water obtained by this combustion reaction, by burning hydrogen and oxygen, or otherwise water collected, pure water collected from sea water, pure water collected from tap water, pure water collected from Panchganga river, or by any means even rainwater also can be collected, but it should not be containing dissolved components in it. It should be pure water only. That pure water in always is a combination of hydrogen and oxygen, and that hydrogen and oxygen should be combining in a fixed proportion by mass. For example, 2 grams of hydrogen will be combining always with 16 grams of oxygen. If I take a simple ratio, every 1 gram of hydrogen will be combining with 8 grams of oxygen. This is law of definite proportions. For any chemical compound in its pure state, the substances combining to produce it will bear a fixed ratio, a constant ratio. Now, let us come back to the definition given. In a compound, the ratio of each element by weight remains the same irrespective of its method of preparation or from the source from which it is being obtained. For example, a molecule of ammonia is taken. Molecule of ammonia generally formula is NH3. NH3, 1 nitrogen atom, 3 hydrogen atoms will be present. This, if I interpret in terms of the weight, I am going to get every 17 grams of ammonia always contain 14 grams of nitrogen and 3 grams of hydrogen. Another example, let us consider, for example, if I am considering carbon dioxide molecule, will be containing 1 carbon atom and 2 oxygen atoms in terms of atom proportion. If I am taking in terms of the mass, in terms of the weight, every 44 grams of carbon dioxide will be containing 12 grams of carbon and 32 grams of oxygen. Means that they are combining in 3:8 ratio. If I take it as 12:32, a simple ratio can be taken as 3:8. With 2 examples, one is ammonia, another is carbon dioxide. The other example we have taken water, in which hydrogen and oxygen will be combining in 1:8 ratio, we made a discussion. Now let us come to a numerical. In the formation of water, hydrogen and oxygen are going to combine in the ratio of 1:8. How much hydrogen is required to completely react with 32 kilograms of oxygen? Please verify, this is given as kilograms of oxygen. Question is given in gram scale and answer he is asking you in kilogram scale. For that, I go for law of definite proportions, law of constant proportions, according to which water molecule every 8 grams of oxygen will be combining with 1 gram of hydrogen. The same thing if I raise to the proportions of kilogram. The same thing I can write here, instead of 8 grams of oxygen with 1 gram of hydrogen, I can raise the quantity to kilogram scale. 8 kilograms of oxygen will be combining with 1 kilogram of hydrogen. So therefore 32 kilograms of oxygen will combine with how much? 1 by 8 into 32, usually 4 grams of hydrogen. Like that we can make some calculations in this. Now, this is a numerical which we need to study. In all the question banks you find this type of question. The weight of copper oxide obtained by treating with 2.16 grams of metallic copper with nitric acid and subsequent ignition was 2.76 grams. In another experiment, 1.15 grams of copper oxide on reduction yielded 0.92 grams of copper. Practically speaking, at this stage, you do not require any chemical equation, since you need to understand what is happening in the reaction. Okay, copper oxide is obtained by combining 2.16 grams of metallic copper with nitric acid. Copper oxide, by allowing this to react with copper and concentrated nitric acid. Don't go to the balanced chemical equation. This is as an oxidizing agent, copper will be converted into copper oxide. Let us suppose that this is experiment 1. The second experiment is conducted in a different way. He took copper oxide and this is subjected to reduction to produce copper. In both of them, we require this scale. Copper oxide is the compound which you need to observe. We do not want the chemical equations. By what method he reduced? Is it by passing hydrogen gas? Is it by using any other reducing agent? It is immaterial to us. We do not require that. Just in preparing copper oxide, how much amount of copper and oxygen are combined? Just we want to know that. So, the experimental data can be kept on paper like this. First experiment, the weight of copper oxide is given this much, 2.16 grams. Weight of copper is given as 2.16 grams. From that, the copper oxide you obtained will be 2.7 grams. So, what will be the weight of oxygen in this process? Weight of copper oxide minus weight of copper will give me weight of oxygen, which was found to be 0.54. So, in what ratio copper and oxygen combined? Copper to oxygen ratio, if I am taking 2.16, 0.54 according to the data, I pick the smallest number, with that I divide, so that with 1 gram of oxygen, how much amount of copper combining I am going to get? Please observe here, 4:1. So, copper and oxygen are combining in 4:1 ratio. In the other experiment also, the copper oxide which you subjected to a chemical reaction or which you prepared copper oxide, whatever may be the experiment, if you are taking the copper oxygen ratio should bear the same ratio, then only the process is found to be correct. So, what I am doing is the weight of copper oxide according to the question given as 1.15 grams, the weight of copper will be 0.92 grams. From this I calculated the weight of oxygen, weight of copper oxide minus weight of copper, I am going to get 0.23. So, copper weight will be 0.92 and oxygen weight will be 0.23. If I am taking the ratio weight of copper to weight of oxygen, I am going to get 4:1. In both process, please do observe that I am going to get 4:1 ratio only, meaning that according to law of constant proportions in the preparation of copper oxide. In the preparation of copper oxide as CuO, as cupric oxide, copper and oxygen are combining in 4:1 mass ratio. Now, let us go to the next slide. Another numerical is given in this. The other numerical which is given is of iron oxide discussion given. Please read the question. Please read the question. In an experiment, 2.4 grams of iron oxide on reduction with hydrogen gives 1.68 grams of iron. In another experiment, 2.9 grams of iron oxide gave 2.03 grams of iron on reduction with hydrogen. Show that the above data is illustrating law of constant proportions or law of definite proportions. Exactly a replica of the previous question. Data given is almost similar. Instead of copper oxide, you are preparing iron oxide in this case. First take weight of iron oxide and what is the weight of iron produced there. The difference between these two will give you weight of oxygen, which will be equal to 0.72 grams. Go to the second experiment. Weight of iron oxide is 2.9 grams and weight of iron will be 2.03 grams. So, the difference will be equal to 0.87 grams. So, based on this data, according to law of definite proportions, substances must combine or elements must combine in a fixed proportion by mass, or each chemical compound will be containing the same quantities of the elements by mass, whatever may be the method of preparation. But for this, there is one important limitation. That limitation, according to one example, let us consider, I am preparing carbon dioxide. Carbon dioxide is being prepared by combustion of carbon in oxygen. Suppose if I am taking isotopes of carbon, carbon 12 is being taken. Here the carbon dioxide produced is also carbon dioxide produced from carbon 12 isotope. So, in this 12 grams of carbon is going to combine with 32 grams of oxygen. Carbon dioxide compound will be same, but I am not preparing from carbon 12 isotope, but instead of that I am taking carbon 14 isotope, which when burnt in oxygen produces carbon dioxide, but this carbon dioxide in properties will be same, but in nature was found to be slightly different from this carbon dioxide. In this case, 14 grams of carbon combined with 32 grams of oxygen. So, when you are considering the compounds which are produced by the isotopes of the same elements, in the laws of chemical combination, law of definite proportions do not work out. Law of constant proportions do not work out, because here the masses of the elements combining will be in different ratio. So, to this you cannot apply law of definite proportions. And one of the success of this rule is, in future we are going to apply a principle called as POAC. POAC is principle of atomic conservation. Means that on the left hand side of the reactants, whatever number of atoms are present, the same number of atoms must be present on the right hand side also. For example, if nitrogen is combining with hydrogen, you are going to produce ammonia. Okay, this will be written in the form of an equation, a balanced chemical equation. N2 plus 3H2 gives rise to 2NH3, means that atoms are conserved. On the left hand side 2 nitrogen atoms, on the right hand side 2 nitrogen atoms only to be present. Okay, on the left hand side 6 hydrogen atoms are present, on the right hand side also 6 hydrogen atoms must be there. So, the first two rules which we learnt, One, law of conservation of mass. Second, law of definite proportions. Both these two led to the proposal of principle of atomic conservation, POAC. In future, we are going to use this method as POAC method in the balancing of chemical reactions and also in making certain stoichiometric calculation. While writing a chemical equation, whatever number of atoms of different elements are present under the reactant side or on the reactant side should be equal on the product side also. Same number of atoms must be present. This is usually called as balancing of a chemical reaction.